Hello, welcome to the second video for how we can find p-values for a one proportion z-test. In the first one, we used a menu. In the second one, we'll calculate our test statistic. That is the statistic about our sample that we want to test. So our sample was 65 randomly selected cereal boxes, and 11 of them contained B's. So if we want to find what is our sample proportion that we denote with p hat, that would be 11 over 65, which is approximately 16.92%. Okay, so if we want to find what is the probability that we would have found that experimental result, even assuming that the null hypothesis is true, we have to look at the null hypothesis sampling distribution. So the null hypothesis sampling distribution tells us assuming that it is really true that 20% of the boxes contain B's, what are all of the different outcomes we might expect to see just based on the random variability of sampling? Because sometimes we might sample 11 boxes and just randomly more of them contain B's, and sometimes fewer of them contain B's. So in our particular case, we ended up here. This was approximately our p-hat. It was 16%. Our alternative hypothesis is that there should be a smaller proportion. So the question is the fact that we found a smaller proportion evidence that we were right and there really is a smaller proportion, or is it just the random variability of sampling? So that's why we find the p-value. We want to find the probability of getting that result or something even smaller. So because we know that the sampling distribution is normal, because of the conditions we didn't check in this video, you can use normal CDF to find this area. So let's look in the normal CDF menu and kind of see how we can do that. You get there by saying second distribution. Normal CDF is the second one down. Mine doesn't display a nice menu, but most calculators display a nice menu like this. And if yours doesn't display a menu, you just enter these four numbers in that order. And here's what the four numbers describe. The first number is the lower bound of what you want to calculate. So that's like what value in this curve represents the left-hand side of the area you want. So for us, that's negative infinity. On your calculator, you would more typically write a very large negative number, which is a very poor approximation of infinity, but will work for us. The upper bound is the value that represents the right-hand side of the area you're trying to find. So that's our p-hat in this example. Could be different in another example. The mean is where is our distribution centered. So for us, that's 0.2. And this is the standard deviation of our distribution. What is the standard deviation of our distribution? Because this is a sampling distribution, the standard deviation is actually the spread of all the possible p-hats. And the name for that is the standard error. And this is one of those equations that hopefully you have memorized by now. So in our case, let's calculate it. So it's 0.0496. So that's what I will type here. And now you can hit paste to find the p-value. If you were going to do it this way on a test, you would need somewhere to indicate that this is a normal sampling distribution. And whenever you talk about a distribution, you have to mention the center and the spread. So you would have to some way indicate that the mean of the distribution is 0.2 and the standard deviation of the distribution is calculated by the standard error. As long as all of that is relatively clear and you indicate that you use normal CDF for the p-value, that should be fine. Okay, let's look at the traditional way that this was done, which is very similar. It's the same idea. We're going to use normal normal CDF. Except now instead of asking how likely is our p-hat to have happened, we'll figure out what's the z-score associated with the p-hat. How many standard deviations is it away from the mean? And then what would the probability of that be? Which is just the same.